Now here is a representation of adding two vectors in a more tangible manner. So let's say we have vector A and vector B. We want to add these two together. So one of the methods we learned was it's called tip to toe. So the beginning of the first to the end of the second or last. So this is pretty much same as you do B plus A. Obviously the same. These two vectors are the same. What if you have three? Again, the same. So you go first, second, and this is A plus B, and then you move C, and this is the A plus B plus C. Very much you can say B plus C, and then you add A, and the result would be very much the same. So you can see that these two vectors are the same. We mentioned that we are not using this. We use instead Cartesian notation, which is much easier. Subtracting two vectors, we talk about when you multiply a vector by numeric -1, it means the direction is going to be the change, the magnitude is the same. So when you say A minus B is almost A plus minus B. So all you do, you change the direction of vector B, and the answer is here. Or you can say simply C plus B is equal to A. So this is C plus B, this is A. Very much the same. Now we talk about Cartesian notation. Imagine you have the red vector A, and both of these vectors start from the origin 0, 0. So this point, which is the end of the vector A, 7 and 4, x is 7, y is 4. So if you want to write down in 2D Cartesian component, it's 7i plus 4j. The green vector is 5i plus 14j. You want to add these together. So as you can see, vector C, which is equal to A plus B, you add I components 12 and J components 18. This is a simple example, shows how the Cartesian components can simply work same as the tip to toe method. Last but not least, we talk about the unit vector. Unit vector on any direction is a vector with the magnitude of 1. So for example, this is I and this is J. So if I go and increase the I, let's say to 3, and this is J, I increase the J to the J to 4. So now I have a vector that X component is 3 and J component is 4, or I can say I have a vector that actually has only I components 3 and J components 4. The magnitude of this vector is square of X plus the square of Y, square root of that, which is in this case 5. So that's an interesting examples here. So if you have 5 and 5, so it's going to be the square root of 50. The unit vector on this direction is I component, which is 5, divided by the magnitude, plus J components, which is 5, divided by the magnitude. And that would be a unit vector, a vector with the size of unity on this green direction. This explains why we use unit vector. We mentioned that also unit vector is very useful. When you have the unit vector, you multiply by any magnitude of any vector in that direction, it gives the Cartesian components of that desirable vector. I hope it explains a little more. There are many other websites online, they have the same representation. Feel free to Google them. Thank you.